Hello. Now we will discuss a conic section specialized on parabola. So what is parabola? Parabola is another commonly known conic section. The geometrical definition of parabola is the locus of point such that equidistance from a point known as the focus and a straight line called directrix. In other words, the eccentricity, the ratio, will be 1 since it is equidistance. So let's see the illustration here. If I have a parabola here with the vertex is 0, 0, then we'll choose any point on this curve of parabola, for example, x, y here. So this x, y, if we calculate, it will be equidistance to the point here and to the line perpendicularly to this line. Yeah, this is equidistance. And also we can try if the point is here. So x, y here is also equidistance to the point and to the line perpendicularly. So later, this line will be called the directrix lines, while the point here will be called the focus. So, for instance, the focus is p, 0, so we can calculate that this point of focus to the vertex is p, and from the point here is also p, so this is equal negative p because it is at the left. Because it is negative p, so the directrix line's equation will be x equals negative p. Then, what about the line here? The line here is called the Latus Rectum. So since it is passes through p, 0, so the line will have equation x equals p. Notice that x equals negative p, x equals p is parallel with the y-axis if the parabola is horizontal. Then the Latus Rectum line equation will be x equals p. What about symmetrical line equation? Why this is y equals 0? Symmetrical line equation is the line which divide the parabola will become two equal parts. So here, the symmetrical line of this parabola, its x-axis or y equal 0. What about the Latus Rectum length? So see here you can see why it is 2p. Please check again this point x, y. Since it is equidistance and the distance here is 2p, p plus p, so from this point x, y to the focus is also 2p. Since the parabola is symmetrical, so this is also 2p, so that the Latus Rectum length will be equals 4p. So the Latus Rectum length goes from this point to this point. What about eccentricity? Eccentricity at the parabola is equals to 1 since eccentricity is the ratio between the distance from any point to the curve to the focus and from that point to the directrix lines. Since it is equidistance, then eccentricity equals 1. What about the parabola equation for this horizontal parabola with vertex p 0, 0? Please check this line. If we calculate the distance between the line, we have x subtracted by p square plus y minus 0 square equal x plus p. Why it is x plus p? You can check here since it is equal distance from this point to the directrix lines. This is x and this is p. This is the y-axis, this is the point x, y. So here the length is x, and from the y-axis to the directrix line's length is p. Then the total is x plus p. X plus p equal tf, the distance between x, y to p, 0. So we can calculate the distance we square both sides and simplify. So here we have x minus p square minus 2px plus p square plus y square equal x plus p square, x square plus 2px plus p square. Then we can cancel some terms out. First, we can cancel x square and x square. And then we also can cancel p square and p square. So what we have left, we have y square, which equals to 4px. So this is the simplest equation for the parabola, which is horizontal and which vertex is 0, 0. Then let's go next. What if the parabola now is translated to the vertex P, A, B? So suppose the parabola is translated to this vertex A, B. Then what we have here, first, the focus still will has the distance of P from the vertex. So now it goes to P plus A, B. The position of the height will be still parallel with A, B. Yeah, it has the same height. So the focus will be P plus A, B. Next, for the directrix line, since this is minus P, this is minus P, so it will has equation of minus P plus A. The minus P is translated, goes A to the right. Yeah, from minus P goes to the right, become minus P plus A, so that the directrix line equation change become minus P plus A. And for the symmetrical line equation from from y equals 0 here, it goes up to y equals b. It goes up because it is also passes through the focus, and the height of the focus now will be b. So this is also b. Symmetrical line equation. What about the latus rectum? The latus rectum, since it is following the x-axis of the focus, the latus rectum equation will be x equals p plus a. Same here. It will be not changing the latus rectum length, still 4p. And then for the eccentricity, it is also the same. E will be equals 1. For the equation from y square equal 4px, we can add the translation. Y is translated b unit to the goes up, so it is subtracted by b. X will be goes right, a unit, so it is subtracted by a, become x minus a. Okay, so also please check for the horizontal parabola, the square or the degree of 2 will be for the terms of y, while the term of x will has the degree of 1 here. Let's check what is the difference between the horizontal and the vertical parabola. First, for the parabola, vertical parabola with vertex P 0, 0. So it will be the same for the vertex 0, 0. Now the directrix lines will be parallel with the x-axis, so the equation become y equals. So it is changed, become y equals minus p. For the latus rectum, become y equals p. And then for the focus, since the focus for the vertical parabola will be goes up p unit, the distance between focus and the vertex is p. So now the height will be added. At the y positions, it becomes 0, p, not p, 0. And the latus rectum length will be not changing. So we can see here This is the part of the vertical parabola. Please notice for the equation, it will be swapping position so that the square, the degree of 2 goes for the x term, and the degree of 1 now goes to the y term. And this is the parabola that we always have at the first grade, with the general form of y equal ax squared plus bx plus c. So the usual parabola that we have is the y with degree 1, and then ax squared, the highest degree of x is square, plus bx plus c. Now we only will adjust here the position, but for the general term it is the same. Yeah, it goes up or down depend on the value of a. So let's check what about the vertex a, b for the vertical parabola. Okay, let's make a correction here. This is supposed to be for the vertical parabola. For the vertical parabola with vertex P, A, B, so it is the same. From the vertex 0, 0, it is translated A, B goes right, A unit goes up, B unit. Then for the focus, it will goes up P unit, so it will change the positions of y. A will be still the same with the vertex, but the b added by p, so it will be p plus b. And then for the y equals minus p plus b, this is for the Directrix Line's equations. Since it goes down p unit minus p and then added by b, so it will be y equals minus p plus b. And for the symmetrical line equations, since it is parallel with y-axis and passes through vertex A, so the equation becomes x equals a. And then this is the Latus Rectum equation. Latus Rectum equation is following the focus of y part. Y equals, because it is parallel with x-axis for the vertical parabola, so it is y equals, and it will be the same terms with the y unit of p plus b. And it will be not changing for the Latus Rectum length. It will be still 4p, and also for the eccentricity it is not changing. So